Hey, I think we're live. I'm seeing something going on. Eh, all right. First live stream on Growling Pigeon Studio channel. This will be fun. So, uh, creating snake game. Yeah, let's do this. Um, really fast. Let's just run the game show. I've only got blue background, and I kind of want to go after sort of the same aesthetic that you would expect from like a DOS game. So like green pixels for the snake that wander around really slow, a black background, that kind of stuff, and maybe even some post processing if we get to it. Not likely though, because post processing is a little bit intense. I'm not terribly good with high level graphics language. Um, I usually have to look everything up as I code HLGL. But at any rate, let's get going. So, main camera, first of all, black background. That's easy to do. And a straight up black is not actually very aesthetically pleasing. So, what I might do is just go a little bit gray, like that. Yeah, I think that'll do it. So if we run this real fast, and making a game like this is constant iterations. I think that's a really good gray. All right, camera set up. Hallelujah. That was so hard. Okay, so in the background, let's actually kind of create a little bit of a grid system. So what I'm going to do is create an empty object, and this will be my grid root. And in there, I'm going to create a sprite, a square sprite. And let's change that color to kind of match what we did with the background. Just a little bit lighter, I think. And let's see what that looks like. Yeah, so if our grid looks like that and we have spaces that turn green, turn red, or whatever, I think that'll hit the aesthetic perfectly that I'm trying to go after. So I'm going to bring the Z to, oh, I don't know, maybe 1. And if we take a look at that, you'll see what that does. It kind of puts it a little bit behind the main grid here. And the advantage of that is we can put things in front of it instead of having to actually change the color, because going through and changing colors might be a little difficult. And of course, if you ask questions in the chat or say hello or whatever, then please go for it. And with questions, I'll try to answer those as I go through. I'll keep looking back and forth. Nothing wrong with that. Okay, so let's keep going with the aesthetic. It's a little bit on this gray side. Let's make it a little bit smaller as well. So we'll adjust the scale. Well, actually, let's create another empty, and this will be square parent. We'll put that under grid root and then the square under that. So what we're doing is we're changing the scale of the renderer instead of the scale of the object itself. I mean, we're changing the child object scale. And so we'll make this 0.75. And it doesn't matter what we do on the z-axis, since this is a two-dimensional object. And that's at 0, 0, 0 and 0, 0, 1. Okay? So it's just going to be a little bit smaller. And then if we have our icons in front of it that are full size, 1 by 1 by 1, then I think that'll look pretty cool. So let's look pretty neat. I mean, let's duplicate this a couple of times and move it up one spot and duplicate that, duplicate that. And again, I'm just right now setting up the kind of look and feel of our game. And these are non-programmable objects. Okay, let's give that a look. I hope you can see that on YouTube through the compression algorithm they have. I might make it a little bit brighter if you guys can't see it. But that looks really good. I'm liking where this is going. All right, so to bundle all that up, let's create another empty object. And this will be a grid section. Put all of this under a single grid section. Let's try to do that right. There we go. And then we can just duplicate the grid section like that. And yeah, it's just a boring copy and paste. And what I'm going to do after this is I'm going to make a prefab out of one of these grids so that if I do need to change something, it will change all of the grid squares all at once. Okay. Of course, we need more for the outer edges. Put that there. Put that there. This would be faster if I do another root object. Create empty, and this will be grid section parent. Why not? I can name it whatever I want. It's my game. All right, duplicate that. And this may not be the most performant thing in the world, but for demonstrative purposes, it doesn't really matter that much. And we'll change the camera size to accommodate all this as well. Let's not actually duplicate that, but instead move everything up. There we go. And then we'll get our camera and increase the size so that we're getting as many of these grid squares as we can, and kind of increase the size of our playing area. Take a look at that. Oh, isn't that beautiful? All right, then let's see what it would look like if we have a green square on top of that. So create another 2D object, sprite, square, and let's make the color green, kind of a snaky green. I think that's good. Snake body is what we'll name it. Let's bring that to 0, 0, so it's right on top of the grid, and see what that looks like. Oh, I need to shift it down by half. So, 0.5. And shift it up, whatever. Beautiful. Okay, so let's make it a little bit smaller. Well, actually, first, let's take this, move it over, and see if there's like a little gap in between. If not, we'll create a little gap. Yeah, there's one. Maybe not big enough. So what we'll do again is create an empty object. This will be snake body square. Put a snake body square underneath that as a child. And we'll make this a prefab. So let's create a new folder for prefabs. Snake body square, we'll put that under prefabs. And now, whenever we alter one, we alter all of them. So we'll delete this guy and make a duplicate snake body. Then we can edit this in context. So prefab. Well, let's move this one over so that it's next door. And 0 on this guy. He should be 0 as well on that axis. 0 here. Oh, no, that needs to be like 0.5. Does it? Oh, no. Now we're getting everything mixed up. Hold on. What's going on here? That's why. So we'll make that 0, 0, 0. Okay. So yeah, that's the idea. Delete that. Come in here, and let's edit this directly. 0, 0, 0. It should be right in the center. And then this guy, also 0, 0, 0. All right. I think we're back in business. Let's also, while we're in here, scale this down just a little bit. 0.8 and 0.8 on that as well. All right, now if we bring this to 0, yeah, that's right on top of the grid. Good. And 0.5. Okay, bring in another one and give it negative 0.5 as its position. And let's take a look at that. Oh yeah, we got a nice separation in between, which looks great. So what we can do, well, right at this point, it's maybe not important to make prefabs out of the grid. I think the grid is going to stay the way that it is. And I'm kind of past the point of no return on that grid. I don't want to go through a whole process of duplicating them again. I suppose I could, but doing that would take some time. All right, cool. So the next thing we need to do is create a snake head. And this snake head needs to actually move around and generate a body that follows the snake. And if we're going for like kind of a DOS aesthetic, then I don't want to have a smooth movement. I want to have a stepped movement, which I think will be a little bit more interesting to program. We're going to need to do like a coroutine sort of setup. So I guess that's the question. Should I go for smooth or should I go for stepped? I'll let you guys answer that in the comments or in the chat. And if everybody says, hey, let's go for smooth movement, then that's totally fine too. We can go either way. This isn't just my game, after all. This is educational purposes. Aren't I cool? But in the meantime, let's create a snake head. Square. Actually, let's do a circle. It's going to kind of kill our aesthetic. If it's supposed to be like DOS-like, right? But I think it works. You were able to draw circles in DOS back in the day. Where's a good circle sprite? All right, we got one person saying smooth would be good. All right, here's the circle. So smooth movement rather than jagged movement. All right, and we want this to be our head, so we'll name it as such. Give it a color that matches the snake color. Let's bring it to, well, let's get rid of the snake bodies for now. And let's bring it down to 0 by 0.5. And of course, we're going to have to give it like a direction and all that. But we're not quite there yet. So, to set up input, there is a new way to do that in Unity. Other people are saying smooth, please. So that's what we'll do. Okay, so yeah, in Unity you have your new input system. I can set that up, but I think for right now, for really quick prototyping, I'm just going to do our input through code. And I can come back and fix that. But right now we're just going to do quick setup in code. So in our assets, we have, and I don't know if you can see this, it's pretty small, but we'll create a new C# script. And we'll call it snake head behavior. Well, actually, controller is better. Snakehead controller. Everybody will tell you that the worst thing in programming is naming things. And it's true. Let me just bring that over. And we'll zoom in real close so everybody can see it, even if you're watching it on your phone, I hope. You can see it on the phone. Okay, we can close out of that guy. So, like I said, we need a direction, and that's probably good to do with an enum. So let's create another script. We'll call this a direction enum. Actually, a direction enum is probably a bad idea. Let's do direction through a vector2. So vector2 direction. And we'll start with up. Vector2 up. So that way, we're going to start by moving upward. Let's give it a speed. So private float speed. And this will be for our smooth movement. And speed will be serializable, so we can change it in the editor. Serialized field. And we'll give it a range as well. So we'll range it between 1, so that's 1 square per second, I think. Yeah, we'll go for that. And, I want to adjust the grid. I don't like having everything on a 0.5 on the y-axis. So I'm going to change that as well. That way, in the code, we can keep everything on these simple integers. All right, so we have our update. And update is great for input, but not great for movement. So we'll do private void fixed update, which is the physics update, and with this we'll actually move forward. So this transform position, and that's a vector3. And and we want to get a vector 2. Now we can plug into our rigid body, attach a rigid body, get it, and set a vector directly, which is actually probably better. So let's do that instead. So we'll require a component type of rigid body 2D. And we'll get a link to it. Rigid body 2D. And no surprise, we'll call it rigid body. And on the start, we'll get a reference to it. So this dot rigid body equals this get component, and the type is rigid body 2D. There's a lot of repetition in programming. I'm so sorry about that, but it's just the way it is. And then this dot rigid body has a velocity, so our velocity will be equal to our direction. Our direction will be updated during the update method, and we'll cache whatever the inputs are so that when we get to a certain square, we'll be able to start moving in the new direction that the player pressed. But we'll get to that in just a minute. Let's actually just make sure that everything is working good, that we're traveling at a good speed. So we run. Oh, that's right. I have to attach the object or the script to the object. So snake head controller onto the snake's head. There we go. It's traveling at a speed of 1 per second. Very good. Now that's obviously very slow. Also, this has gravity on, and we don't want that. Where is our gravity scale? There we are, 0. In fact, we can go into our settings and turn off gravity for everything. I'm not going to go and do that. Setting the gravity scale is just fine for a project this small. But there is a way to go into settings and turn off gravity globally. All right, and then we're going to change the speed to, let's say, I don't know, maybe 8 per second. Probably a good speed. We're not multiplying by speed yet, are we? We just have direction. That's why you test. That is why you test. So this dot direction multiplied by this dot speed. Okay, now let's test that. Oh yeah, that's much faster. Maybe a little too fast. Let's bring this back down to like 3. Perfect. That's a really good speed. And as we kind of play it and stuff, we'll see what happens. Now we obviously need to add a collider to this so we can tell if we've hit something, and we'll get to that. But first, let's do our input so we can change direction and then test that. So on our update, we'll be able to change our direction. And I'm just going to do a whole bunch of if statements. So if input get key code, and we'll control with WASD. This direction equals vector 2, and that's up. And of course, our value is already cached, but it's going to automatically change our movement, and we don't want that. We want to get to a integer location on our grid. You know, what do you call it? An intersection on our grid. if Rene Descartes was here, he would tell me that I am saying everything wrong and that I need to go back to school and learn math again. And if Euler was here, he'd probably say the same thing. All right, so S, for example, is right. And this will be left, which is A. And then D, sorry, D is right, and S is down. Okay, and this setup is kind of a lazy setup. Normally what I would want to do is say, hey, if I have two buttons being pressed down, then take whatever our last direction was. But what this does is say that I'm pressing W and S at the same time, then it's going to say that I'm pressing down because S is after W. So we'll say, oh yeah, you're pressing W, so that's up. And then you're pressing down, so that's down. And so on. So if I was pressing D, for example, or if I was holding down all of these keys, then it would move right. Which, may not be desirable, but for this game right now, that's what we're doing. Okay. And then we also want to hit an integer location. And to do that, we probably want to say, hey, do we get within a certain distance, because we don't want to overshoot. And we can kind of talk about that as we try to solve that problem. Let's just make sure that our input works first. But the idea is, oh, look at that, that's beautiful. Now if I hold down W and D at the same time, then you'll notice I'm still moving right. And that's what I was talking about. If I press A and D, then I move right. So kind of lame that way, but whatever. Okay, so let's move our grid up by about half. Yeah, that looks about right. Is it right? Yeah, it's about. It's good enough. Then we'll bring our head down to 0. That way it's right in the center. Our grid is kind of misaligned. That way. I think that's better. Okay. Yeah, that looks better. Let's move around. Yeah, that's pretty good. Now, obviously, these squares above our camera need to be included. And then we also need to have like an out of bounds and all of that stuff. Let's see, I have the camera now, right? I selected one of the grid squares. I don't want to do that. Right, our camera. Let's increase the size just a little bit so that we capture those grid squares. Okay. Yeah, and we'll have to set up an out of bounds. Maybe, well, I mean, the original Snake game, right, if you go out of bounds, then it's an automatic death. So we'll just do something simple like that. You go out of bounds, you automatically die. All right. So as far as the grid goes, we need to make sure that, well, I mean, the snake head goes. We need to make sure that we are hitting some sort of corner or an intersection before we change direction. Okay. So, how are we going to do that? I guess what we can do is last position, so private vector 2 last position, and when we start, it's whatever our current position is. So last position equals this transform dot position, and that automatically casts into a vector 2. So that's a vector 2 and this is a vector 3, but it does an automatic conversion, which is nice. An implicit cast. And then what we'll do is have a target. So private vector 2, this is our target position. And let's create another method. Private void set target position. So what we'll do is we'll take our current direction and add that to our current position. So this dot target position equals this dot current or last position, there we go, plus this dot direction. That's good. So now we can set our target position here. And then on our fixed update, we can also say, hey, if we've gotten past a certain point, then we can update our target position again. So, I guess we would get within a certain distance. So if this dot transform position, and we'll want to cast this, do an explicit cast. So this is to vector 2. And we'll need to do some math on this. Actually, we don't need to do an explicit cast if we're going to do our math. So vector 2 distance. So transform position, and this dot target position. So that gives us our distance. In fact, we can, our line is getting kind of long, so let's break this up. Well, actually, this is going to be a float. Distance to target equals that. Let's create a new line. Again, because we're getting kind of long. All right, so if distance to target is less than, let's say 0.15 or 0.5 f. Okay? So if it's less than 0.05, then we will say that we've made it there. So this dot latest position, last position, equals this dot target position, this dot transform position equals this target position. So we're snapping it, right? And then this dot set new target position. So we're going to get a new target position based on what our direction is. And we also need to set our direction. So here's our direction. Let's create a new one, and this is our cached direction. That way we're not crossing wires. And then these will update our cache direction. Okay. And then here we'll update our cache direction. So this dot direction equals this dot cached direction. All right, if I did everything right, then when we go over to Unity and press play, then it should go from square to square. And it should do so smoothly, like people were asking. Nope. I was pressing down, but it wasn't updating. And I think the reason for that is it's not getting within that distance of its target position. So if I were to describe, well, let's pull up Paint. This is a great teachable moment. So I think what's happening is this is our allowable distance, and say that this is the point that we want to get to. Honestly, that should have been red. Whatever. So let's say that that's the point that we want to get to. Is in red. Then what we're actually doing is our position is here, and then the next fixed update, it's over here. And so it's never triggering because our radius is too small. So to fix that, what we might want to do is say, all right, so since I'm here, let's look back to our latest position, and if it's beyond our target position, then that also counts. That takes a little bit of extra coding, but I think that's what we want to do to make that work. Okay. Or what I could do is do some angle math. So let's say that we've got our target position in red here, okay? And our last position is in blue, all right? And our current position is in green. So we're in between our last position and our target position. If we draw now a line like that from both points, then what we'll see is that they have the same angle. Since we're dealing with our simple cardinal directions, we're going up, down, left, right, we're not doing anything kind of in between. We know that our angles are going to be pretty simple and easy to distinguish. So this, for example, will be 1/2 pi. This is a line tool and not a writer. But yeah, it'll be 1/2 pi. But when we're beyond our target position, let's get our brush again. If we're beyond our target position and we draw a line, then suddenly this has a different angle from the previous view. So I think this is actually going to be an easier way to do it. It doesn't have all the if statements that the other way would have, looking at the x and y positions. So we'll just simplify that. So distance to target, we'll get rid of all that code. What we'll do instead is bool past target equals, we'll start with false. We'll assume that we have not passed our target. Then math f atan 2, and this will give us radians as described. So this will be this dot last position dot y subtract this dot transform position dot y. I want to make sure that I'm doing this right. And then this dot last position dot x subtract this dot transform position dot x. So this is current angle, and that's a float. So current angle and then target angle. So this, it'll be this dot target position. Like that. So if we've passed our target, then these will be different. So We can actually move that down. We don't need to assume false anymore. We can just directly assign it. So current angle does not equal target angle. Easy peasy. So if the distance to target is less than that or past target, then we will snap to our grid position. So let's make sure that that works. A little intense. I hope it does. Otherwise, I'll look like a darn fool. Oh dear, that snaps a little too hard, doesn't it? Shoot. Trying to understand what's happening. So when I press a key, then it just jumps to the new target position rather than jumping to the current target position. So am I updating the target position correctly? Target position. And then, yeah, we're setting it down here after looking at everything. Distance to target. Current angle. Transform position and target position. Set target position. Well, what if we say, hey, let's just put it into our last position. So just let's see what that does. Since we're doing a jump and our last position should always be what was before, maybe that'll work. Maybe. No guarantee. Oh yeah, we're still snapping. Snapping to the next square in a really ugly way. So obviously that doesn't work. That last change. So we'll undo. Yeah, any input, if anybody sees the obvious bug. But I don't see it immediately. I'm not entirely sure how to fix it. Obviously, we want to fix this before we move on because we're going to have a collider attached to the head, right? Which will tell us if we've bumped into ourself or into food or into a wall. So this needs to work properly. Maybe if I just do this. So we're not going to snap our current position. So what we'll do is X that out. X out that line. And then what we'll do... So by doing that, our angles can be very similar, but not exactly the same. So that's a problem. We need to change that as well. And what we can do is take this whole number, divide it by mathf dot pi is probably a little too much because that's half a circle. We want to go to a quarter of a circle. So divide by pi divided by 2. In fact, we'll actually turn this into a method. So let's do that instead. Create a method down here. Private float clamp angle. Take in our angle in degrees, or sorry, in radians. Then const float quarter turn equals mathf dot pi divided by 2. Okay. So what we'll do is return radians divided by quarter turn. So if it was a quarter turn, now it's a 1. If it was a half a turn, it's now 2. And if it was a quarter turn in the other direction, then it's a -1, is what we've effectively done. And if it's at no turn at all, so if it's pointing directly to the right, then it's 0. So then we'll floor it. So mathf, and that's not a car pun. It's actually math. We're going to do a floor operation. So what that will do is say that, well, actually floor is not what we want to do. We want to do round. What floor does is it goes to the next lowest integer. So if we have like 1.999, then it will round it down to 1. We actually want to round. We don't want a floor. And then the antithesis of floor is ceiling. We can ceiling something, and if it's like 1.0001, it'll ceiling to 2, which is very nice when you're dealing with certain operations in math. All right, so we got our quarter turn. We're now rounding it to the nearest integer, and then we can leave it like that. We don't need to multiply it by quarter turn again to bring it back to its original value. So we'll just kind of keep it in the range of about -1 to 2. So clamp angle. And this can actually be static. We don't need, because we're not doing anything with our own data. Static, private, static float. Okay? And then CodeMade obviously pushes it to the top because it's a static method. Clamp angle. And clamp angle. And again, that's a really long line, so we'll bring it down a little bit. Just so that all the code is on the screen. We don't have to scroll side to side. All right. I think that'll work. What will happen is, I suppose it will eventually kind of go off screen. Or not off screen, off of the grid system. So we do want to start bringing it back kind of to the grid system instead of getting off. So what we want to do is lerp our position instead of setting it directly like this. So what we'll do is this dot transform position. Don't floor it. SpongeBob's driving test. Very nice. You're good. You're good. That's funny. I heard a story about someone doing that to a friend of mine. Ended up hitting a fence. Something about younger brother and friend of the younger brother. Something like that. I'm sure someone in the chat will know exactly what I'm talking about. Okay, so our position, we will lerp it. And we need to lerp it toward No. Because it requires a time component, and we don't really... We'd have to reset the time component down here. That can kind of get a little bit messy. I mean, it's doable. Direction. What we could do, actually, is instead of setting cache direction, target position. Oh my gosh, I figured out what the bug was. When you set the target position here, right? No, never mind. Never mind. Yeah, this happens to me all the time. I think I know what's wrong, and obviously I'm wrong. Okay. So this, what we want to do is kind of give it an angle. So like back to our drawing. Let's erase all of this. So let's say that we want to go to... I want to get a bigger size brush. All right. Let's say we want to go to this position, and the position that we were last targeting is here, right? And so our current position was here. Now we're here because we moved past, right? And so now we say, all right, this is our new target. What it's currently doing is moving in this line, which will obviously cause problems. Because it will start getting off of the grid. What we'll want to do is actually do more of this kind of an angle. So that's what I'm kind of humming and hawing over. And to do that, I'd have to get some sort of angle. This is obviously a right triangle, right? Where we have... This is the angle that we're concerned about. So this would be our adjacent, and this would be our opposite. Sorry, this would be our hypotenuse, and this would be our opposite. And it's possible we'd have to reconstruct a vector, and that goes into like Euler's equations and all of that. And I really don't want to go into something that complicated. So I think what we'll do is a lerp. So let's get a time private float move time equals 0. Always starts out at 0. And on update, this dot move time plus equals time dot delta time. If I can do that right. Delta time. Okay. Then this dot transform dot position will equal this dot last position. Well, it needs to be a mathf lerp, right? Dot lerp. That only does floats. Hold on. We want to do vector2 dot lerp. And so yeah, this is this dot last position, and this dot target position. And our time component is this dot move time. Okay. And then we'll come down to where we have our reset, and we'll change move time. This dot move time equals 0. Back to 0. 0f. because it's a float. And then we'll get rid of this line. Now, of course, we need to implement speed here. So, or introduce that, so we'll multiply this by this dot speed. And I think that'll do it for us. So lerp is, linear interpolation. Let's go back to Unity and check that out. Oh, I missed a semicolon somewhere. Yep. That makes sense. Okay. Oh, look at that. Beautiful. Perfect. So when we hit a square, it moves exactly as we would expect. It's not going off a little bit per, over time. It's doing a great little thing. Cool. Oh, man, that's so awesome. I'm so glad that works. Okay, now let's introduce food. So create empty. This will be food. We'll put it at 0, 0. And let's actually put this a little bit below the player, so 0.5 on z-axis. Now let's bring it up to like 4. That's a good position. Now let's make ourselves work for it. So it's a 7, the x-axis. Okay, and then to the object sprites, and we'll get a circle. Kind of make it like an apple sort of color. And scale it down 0.5 maybe. Is that too small to see? Let's do 0.75. Want it to be big enough that we can see it, even if you're watching on a phone. Okay, yeah, that looks nice. So obviously right now we're just kind of going over the food. Now, typically, things that you want to avoid are red, and things that you want to eat are green. So let's switch up the colors here. Let's change our head color to red. And our food color to green. It's kind of a sickly green. That's better. Okay. There we go. It's still an apple. It's a Granny Smith apple. It doesn't have to be red. And then, of course, we want to do the same thing to our prefabs. So if we go back to our snake body square and open that up, make sure that its color is red. Okay. Now let's add colliders. So our head has a rigid body 2D, which means that it will be able to trigger any collisions. So let's add a collider. We'll do a circle collider, 2D. And make sure that that's the right... Oh, yeah. Automatically the right size. Perfect. And this is a trigger. Is trigger, yes. Is that all we need to do? I think so. And then on our food, add a component, circle collider for it as well. And let's size that down properly. There we go. Very good. And let's give this a layer, a food layer. Okay. Put it on the food layer. So when we do a collision, and we'll add that here, after the fixed update. So private void on trigger enter 2D. And it has to be 2D, otherwise we're not going to actually get this callback to work. If collider 2D we need to get our layer. Oh, it's our collision, sorry. Collision. Game object get layer. And let's store off the food layer, because I don't want to have to get it every time using a string. That's actually really dumb. Really inefficient. So we'll create some local variable. We'll call it food layer. And it's layer mask get I don't want a layer mask, I want layer. Name to layer. And the name is floor. Sorry, food. Food layer. Private int food layer. And we'll just log something out right now to make sure that we're actually making that collision. So debug log found food. And of course what this will do is make the snake grow, right? Let's go back over to Unity. There we go, food, found food. So yeah, we are getting our collider just perfectly. So now we need to figure out how to create a body for our snake. So what we can do is kind of get a, well, first of all, let's destroy our food object. So destroy collision dot game object, and we'll create more food later on. And private list vector 2. Oh, what should we actually do? We should do a to and from. So let's go back into Unity and create a new script. So this will just be a data object, C# script, and this is a snake body position. Like I say, this is just going to be a data object. So we want to reference to our snake body object, so game object. and body piece, we'll call it. Maybe body square. We'll want a public vector 2 last position and a public vector 2 next position. And then public void inherit position. We'll take our whatever's previous in the link. So inherit positions, and this will be snake body position, and this will be what should we call it? Leader. Okay, and then yeah, so our this dot last position will equal leader dot last position, and this dot next position will equal leader dot next position. And public void set current position float timer, or time component, we'll just call it time. So what we'll do is we'll kind of pass down the time to all of its consecutive pieces, and we'll actually kind of do sort of a chaining system here. So let's actually do a public game object next. We'll start out as null. And when we create, we'll also need to create this we'll pass in a game object. Actually, we'll do some, yeah, we'll pass in a game object that it'll track. Body square vector 2 last position and vector 2 next position. And this is a parameter, so it should start with L. So this dot body square equals body square. And this should be pretty obvious what I'm doing here. Last position equals last position. How you doing, Charles? All right, so we'll set our current position. So this game object, no, it's not game object. I just wrote it. It's body square transform position equals vector 2 dot lerp dot last position dot next position, and this dot, or sorry, the time that we're passing in. Okay. And then if next, so if this dot next is not null, so is not null, then this dot next set current position. Next should be not a game object, it should be a snake body position. Okay. Set current position. Using the time that we passed in. And then add link, public void add link. And this will be body square. So what we'll do is, the idea is that the head will have a single body link that is tracking. That will be null or positive or null or whatever. And that will allow us to just call add link to its body position that it's tracking, just the one. And then it will propagate all the way to the back. That way we don't have to track all of these positions. I think that'll make things a little bit easier. It'll be a little bit heavy on the stack, but in a game this small, I don't think it really matters. So, if this dot next is an object, I use curly braces. How dare I? Let's fix that formatting. Then this dot next, add link, and it's the body square. And return. And then, if not, so if next is null, then this dot next equals new. Make body position. And we gotta pass everything in. This dot body square, this dot last position, and this dot next position. Well, body square, obviously. That's what we're adding. And then last position, we're going to have to figure that out. So for right now, we'll do vector2.0. Kind of start in the middle of the screen, and it'll move up. But yeah, I'm going to need to figure that out. And next position, this dot next position will be its, oh sorry, this dot last position will be its next position. I hope that makes sense. If not, ask. I'm sorry to lose you, Becca. You have fun. Add link. So yeah, this is going to be a problem if we have a collider, because it could conceivably start in the center where the player head currently is, and you blow up just by eating food. That's a serious problem. I'm not entirely sure how to fix this, other than, okay, when created, this might be clever. Well, no, because it will start created. We'll kind of come to it. We'll get an idea of what we need to do next. But oh no, I have an idea. We'll add one more position. And instead of last position, this will be like previous position. No, it's basically the same name as last position. Let's see. So this is going to be before our last position, and this will be the new last position for whatever our up and coming space is. And we only need to track this if we're at the tail end, right? Because we're only adding. So this will be like tail position. There we go. Tail position. This dot tail position will equal vector2 dot 0, which actually I can do up there. I don't need to do it here. Okay, and then when we inherit our positions, this dot tail position will equal this dot last position. And we're only going to do that if this dot next is null. Okay, and then here we can say this dot tail position, because that's guaranteed to have a good value at the very end of the tail. Okay, I think that'll work. So the only trick here is we're going to have to create our game object and feed it in when we create a when we add link. So we'll start obviously with our first one, and well, let's go back over to the head controller and kind of figure that out. So this is snake body position, and body position, and this will we'll start it off with null, so we don't have a body at first. I think in most snake games you start with like 5 segments or something, but we're starting with 0. And so private void update body position, and that's float. Well, actually, we don't need to pass that in because it's local. So if this dot body position has a value, so if it's not null, then this dot body position set current position using this dot move time. Okay. Then private void actually, let's put in a boolean as well. So bool next square. So if we're on our next square, in fact, let's do this. If this dot body position is null, then we'll just return early. Just return. That way we don't need to do everything inside of an if statement. Okay. And this dot body position. So yeah, if next square. So if we're hitting a next square, then we'll need to update all of our positions. inherit positions. And we need a new one that allows us to use our self. So vector 2, last position, vector 2, next position. Okay. So this will be last, this will be next. And then this will actually use that guy. This dot inherit positions using the leader. Ain't that clever? That way we're not duplicating code. Yeah, that looks great. So come back over to the head controller. And so this will be this dot last position and this dot target position. So all we need to do now is add a tail whenever we eat food. So private game object tail prefab, and this is serializable. So when we eat food, this dot add a tail. Okay. Private void add tail. I'm doing this in a new method just so that I don't have a really ugly method up here, because this is going to require a little bit of logic. So if this dot body position is null, then this dot body position equals new snake body position. We obviously need our prefab, so var body square equals instantiate, and what we're using is this dot tail prefab. Okay. And we need our body square. This dot so its next position should be this dot last position. And so we obviously need to track a tail position as well. This dot tail position. So we're kind of doing a lot of the same code, and this there obviously is a better way to do all this, but here we are. And then we'll return early. Otherwise, so if the body position is not null, then this dot body position add link and it's body square. So tail position, we need to add that. Private vector 2 tail position. And of course, the tail position will update here. set target position. This dot tail position equals this dot last position, and that should be before we update our last position. Okay. And then are we calling this add tail? Yes. We eat food. Very good. So let's go back over to Unity and make sure everything compiles right, because we added a lot of code. And on our head here, we need to add a prefab. Right? So snake body square as our tail prefab. And let's add a couple more foods. Well, first of all, let's make this a prefab as well. Good. Now we'll add a couple. Just so that we can kind of get a little bit more of a long tail and make sure that our code works correctly. Let's eat one. Just put it down there. All right. It looks like we do have squares being popped up. So we're just not setting things right. And obviously right now if I touch the body, then it doesn't do anything. Because we don't have that set up yet. That'll be next after we get this fixed. So add a tail. What we do is correct here. We have a snake body position. So it's no longer null. All right. Oh, update body position was never called. That's why. Update body position. And that requires time, right? What does that require? Next square. Whether or not we've hit the next square. So this is obviously false. And in here, it'll be true. Okay. Let's see if that works. What bugs will we run into now? So Stephanie wants to know, how's Death by Cuteness going? Nice plug, thank you. Oh dear. Well, we do have some sort of body. That's not usually how the body works in Snake. Anyway, Stephanie was asking about Death by Cuteness, how that's going. We're going great. We have really cute bunnies now, and they are truly amazing. Oh my gosh. This is so funny. What am I going to do? What even is this bug? Why is it doing that? If we move this up before we get our target position, right? Okay, so yeah, this needs to be all the way up at the top of this little section. Obviously, move time should be 0 on it. So let's try that. think. And let's move this down here. The idea is that this will set it back to the previous square if we don't do that. Okay. Let's see if we get a body now. One that, doesn't do weird things. Okay, excellent. Well, sort of. We fixed half the problem. That is so funny. I think that's inside of the snake position logic. Set current position. Well, obviously that's working correctly, so it's inherit positions, I think, is the problem, the culprit. Inherit positions. We're not causing next to do anything. So, all right, so if this dot next, well, actually this should be as an else. This dot next dot inherit positions. And we'll inherit from this. I think that's what we needed for our propagation logic. Okay, let's run that. Very good. Now we have an actual body that's doing what it's supposed to do. Something that we could do is, as you get a longer tail, you go faster. Now, of course, one problem that I'm seeing as well is when we turn, it actually intersects that first body. And yeah, I can go through myself, of course. I want to see if I can kind of cheat this. Because what I might do is make the first tail piece non-interactable, and that way it can intersect like that and not cause a problem. We'll have to see. Charles says that the bug adds a lot more movement. That bug where we were having things flipping around. Fun. Yep. Sure does. Okay, what were we doing? Right, so I'm noticing one thing. When we grab food, it starts at the 0, 0. And I think that's because I've neglected to update the tail position. So let's go in and do that. And let's see. Now I'm updating tail position. I haven't neglected that. Oh, the reason is that when it's instantiated, it it's at 0, 0. So let's give it its start position. So new transform position equals this dot last position. And it's squawking at me. Oh, it doesn't want me to instantiate transform like that. So, what do we do? Can we just give it a position? Oh yeah, we can do a position and a quaternion. We'll just do a quaternion identity. So, this dot last position and quaternion dot identity. I think that'll work. Okay, good. And well, it looks like maybe it's starting right on top of the player. It's going to last position instead of tail position. And of course, that tail position is going to be different if we have a tail, or it needs to be different if we have a tail. So, obviously, tail position. But what I'm going to do is this dot calculate tail position. Because I want to get something that's a little bit more accurate, that's right at the very back. I just don't want to have some sort of accidental intersection with your tail when the tail's created and have the player die. That would be so frustrating. And let's also new line these because it's getting really long. And private vector 2 calculate tail position. And if this dot body position is null, then return this dot tail position. Very good. Otherwise, and we'll create a new method, this body position get tail position generate method vector 2 public, and if this dot next is null, then return this dot tail position. Otherwise, return this dot next get tail position. So again, this will kind of go down each link and try to figure out what the tail position was and send it back. Okay. And then back over here, we need to return this value. All right, if we run that, that should be really good code. Really clean. Not clean, but really successful. Yeah, that's looking really good. Fantastic. All right, so obviously we need to have a fail state. So when you hit your own tail, you need to fail. So we can start by saying, hey, are we alive or not? So private bool alive equals true. Okay. And on trigger enter 2D, if collision game object layer equals this dot player layer, we'll have to add that as well, then this dot alive equals false. And we're only moving forward, obviously, if alive is true. What we can do is up here. If this dot alive so if we're not alive, then we'll return early and not do any of this logic. There we go. And then, of course, a little pop-up that says, hey, you know, you died, you lost. And I think that'll be enough. I mean, obviously, we need edges as well. So maybe instead of player layer, this should be death layer. Death layer. Okay. And let's add that here. This dot death layer. And we'll just call it death. Okay. Metal name, Death Layer. Very nice. Alright, so let's go into Unity and create that layer. So layers, edit, we'll add def. And then snake body square, we'll go in here, and layer will be def. Yes, change children. Oh, so Charles is asking, how do we set up random positions for the food to show up? That's right. We do need to add that functionality, don't we? Don't worry, Charles. We will do that. But yeah, we'll have to set up some like nodes where food can be created at. And then we'll have to like test for the presence of, well, actually, I suppose the food could appear where the body is, because the body isn't going to interact with it. So that should be good, actually. All right, so let's create a new prefab based on the snake bodies square. So we'll copy it. Right, and copy it down here. Create an original prefab, and this will be snake body square with trigger. Okay, we'll go into that, and we'll add a component. That's box collider. Sorry, yeah, box collider 2D. And is trigger. I think that's just fine as far as, well, let's bring down the size just a little bit so that's more fair for the player. 0.5 and 0.5. Perfect. And on the snake head, we need to add another prefab. And this is tail with collider prefab. Okay, and then back to adding tail. So this will have our normal tail, body square prefab. So let's put that down here. No, actually, what we'll do is decide what prefab we're going to use. This .tail prefab. So that's this dot body position is null. So if null, we'll use normal prefab. Otherwise, this dot tail with collider prefab. Okay, that way we create the collider version beyond where the head is. So right after the head, we'll have a normal tail piece, and then we'll have the collider tail piece after that one. We're almost at 2 hours. So we may have to call it good here in a minute. Hopefully we can get to the point where we do collide correctly with ourselves. I think that we're already at that point. Well, no, we're not, because we don't actually have our prefab set. So tail with trigger. Let's put that in. Okay, now let's try that out. So I can go through myself and no problem. Okay, add a new one. And then if I try to go through myself, it collides and stops moving. Perfect. So now we need a little pop-up that says, "You lost. You loser, you." We'll create a panel. And let's see this canvas. Screen space on the camera. We're using main camera. Very good. And scale with screen. And on the panel, we'll need some text that tells you that you're a freaking loser. So UI text. You're a dead snake. And the color for that, yeah, let's go with bright green. Confuse the player, make them think that green is good. Okay. If I look at that, yeah, that's appearing behind everything. Also, the text is really small. Let's balloon that text size. That's appearing behind everything. So our canvas can't be. Let's do overlay. All right, that should be good. So now if I play, yep, you're a dead snake. So we'll zoom out to kind of look at what we're doing. Our text needs to be a little bit wider. Let's increase the height as well and really pump up that size. Okay, let's try that out. Yeah, that looks awesome. And then the panel, let's make that a little bit more opaque. There we go. Try that out. Beautiful. All right, the panel obviously needs to start out disabled, and then we need to enable it when we die. So we need a new script. Or no, rather, actually on the head. So I'm like doing everything on the snake head script. And you know what? I don't care. Not supposed to do that, but who's going to stop me? Not the text chat, that's for sure. You guys can't stop me. And so this will be our death UI. And when we start, or sorry, when we die, then this dot death UI set active true. Okay, so it'll appear when we die. Back into Unity. And that'll be our panel. So let's go back to our head. Add the panel. Oh, what happened? Why don't I see it? Because I did not make it serializable, that's why. Okay, got our head. Add on the panel. Yeah, the panel. It went out of the event system. That's why. Okay. We've got like 7 more minutes. Can we make this work? Oh my gosh, it's moved. Panel should be at 0, 0, 0. Okay. Are we good now? Is it going to look right now? All right. And then panel, let's toggle you off. Let's eat some food. Get a tail. Bump into ourselves. And look, it says you are a dead snake. Fantastic. Next, we will need to very quickly add our out of bounds. So create an empty object. Let's move it down to 0, 0, 0. Go back to 2D. This is out of bounds. And add a component box collider. We'll make this the same size as the camera or thereabouts. Okay. Actually, we'll bring it in. And yeah, this is a trigger. Add a layer. Instead of the death layer, this will be bounds layer. Okay. Use the bounds layer. Go back into our snake. Private int bounds layer. And this dot bounds layer equals layer mask. Name to layer. And we used bounds. And only got 4 more minutes until we're at 2 hours. Oh no. So on trigger exit 2D. And if collider or collision game object layer equals this dot bounds layer, then once again will die. So this dot extract die. So then this dot die. That way I don't have to write the same code twice. Because every programmer knows you never repeat yourself. Of course, every programmer, when they say that, they repeat themselves by saying, you never repeat yourself. Okay, here's our die method. Go back into the game, eat some food. Well, we don't have to eat food now. We can just see if going out of bounds will kill us. Yep, there you go. 5:58. We basically have a game. The only thing remaining is having the food show up at random locations. And we can do that real fast. I'd have to create a little script, but that would probably put us a little bit over, maybe like 15 minutes over 2 hours. What do you guys say? Do you think I should do that? I'll wait for that to come in. In the meantime, I'll just play. You think I should go through and make our food come in random locations? Takes a while for people to kind of vote. But no, this has been kind of fun. I mean, I ran into some problems that I didn't expect. Like, for example, what happens when we go past a certain point. I'm glad that you guys pushed me to do a smooth movement for the snake instead of a jumping movement. And so, I mean, that gave me some problems that I had to work through that I wasn't expecting. Also, trying to figure out those bugs, that was kind of fun. I might make a little short where I had that bug. I don't know. It was really hilarious. It looks like we got one person responding so far. Named Death Layer. So Charles is saying that I should post it to itch.io and call the game Death Layer. Most metal snake game name ever. I'll add some like music from Styx in the background. Obviously a bad idea. I would get copyrighted so fast on that. Okay, so one person responded, and so since it's just one person, that means 100% of the people want me to go through and do random food drop locations. So since I already have the bounds, I'm actually going to kind of use that for my drop location system. So this goes, what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I do it in a 25, negative 12 to positive 12 in the X and Y, and then test if it's within the bounds, then I can drop food there. So that's what I'm going to do. So we'll create a new script. And this will be food dropper. Let's do stuff with him. So private game object food prefab. And that's serializable. And we'll also need, let's go back over into the snakehead controller and get the logic that we used. I mean, while I said that programmers never repeat themselves, this is a great example of when to do a static method. So I'm going to get, or a static object, a static class is better. So I'm going to copy all of these out. Well, actually, that static class would do exactly the same thing that layer mask is doing. So it would be incredibly redundant. So never mind. I'm just going to literally just take this same code, copy and paste it. So I am repeating myself, but it's okay because it's already minimal code. So private int bounds layer. Okay. And we also need to say that food has been eaten and we need to drop a new food. So public void drop new food. And we said it was going to be from negative 12 to positive 12. So const int test space equals 12. And bool placed food equals false, and while placed food is false, we're going to keep trying to place it until we're successful. So new vector 2 mathf dot random. No, sorry, it's not mathf, it's just random. And the range is going to be a float. It has one overload. And I think that's an int. Yep. And I'm actually going to do vector 2 int. There we go. So it's test space, negative test space, to positive test space. So that'll be our x value, and then our y value will be the same thing. then we need to decide whether or not that is within our bounds. So, what's the best way to do that? I don't know if you can actually test that. I guess you can get the rectangle off of it. In which case we don't need the bounds layer, we just need our bounds object. So private game object bounds object. And actually we'll do a box collider 2D. And this is our bounds box. And then we can do some math operation on that. And so we can get rid of this start. And bounds box. What are we going to do here? If this dot bounds box. I think you can test if a point is inside. So get instance ID. Get component. Get contacts. Is there a way to get the rectangle? Maybe the shape off of it? Nope. Okay, I have a better idea. Here's what we're going to do. What we're going to do is we're going to create a food at a random location. We don't care what it is. In fact, we don't really need that code either. But we're going to move it over to somewhere else. So what we're going to do is we're just going to create food blindly. So it could be off the screen. And what we'll do is on the food, we'll create a script that says, hey, am I within the bounds? And if not, then I'm going to destroy myself and... no, that's so dumb. Let's actually do test space X. I was only doing this to kind of show how we can use like a bounding box. Obviously, that's not going to work. So what I'm going to do is I'm just going to hard code some values. And this is really bad practice. I mean, like really bad practice, but it works for the game. We can get rid of our bounds layer. In fact, we don't need any of this now. And our test space Y is not going to be 12. So that's X, right? But for Y, we want 1, 2, 3, 4, 5, 6, 7. Okay. So 7. Another way that we could do this is like set up a whole bunch of empty objects at certain locations and have those all as our like locations that we can create food, and then randomly select one. And that would be actually a really good way of doing things. But I'm lazy, so I'm going to do things the bad way. So this is guaranteed to put food in the game grid. We just need to call it. So drop new food. Okay. Well, let's go into the snakehead controller. And we need this guy, serialize field, private, and this is snake body, oh, sorry, food dropper. Actually, I don't want to do any of that. I can just search the hierarchy every time that I need it, because this is only going to be called like once every, 1,000 frames. You're not going to be eating food over and over and over, right? So I don't really need to cache that value. So update, and then when fixed update, on trigger enter, add tail. So what we'll do here is find object of type, and this is food dropper. And again, I'm doing things kind of the lazy way. And I'm going to assume that I'm guaranteed to get one, which means I need to actually add it to the scene. Drop new food. So we've eaten, and we're saying, all right, we need to drop new food. Okay. Back into the scene. And we'll actually add it to the main camera. Why not? So food dropper will add to the main camera. And we need a prefab. That's our food prefab. Okay. And then we can delete all these foods. I think everything will work, so let's just run it real fast. Let's eat. And it did not create a food. We also didn't get any errors. What happened? Maybe it can't be on the camera. Maybe we need to put it on. I don't know, we'll put it on. So remove component. Well, let's copy a component first and then remove it. And let's put it on a new object. Create empty. And because I'm so anal, we'll put it at 0, 0, 0. And this will be our food dropper. Add a component, food dropper, and paste component values. Okay. Hopefully that works. That did not add a new food. So what's wrong? Drop new food. All we did is we created a new position. Oh man, do I feel like an idiot. So instantiate. We need to actually instantiate a new food. This dot food prefab at point and quaternion identity. And this should not be an int here, but these should be ints. All right, let's try that. Oh, look at that. We have a game. The food randomly generates. It only took 2 hours and 16 minutes to make a snake game. I really like the way that the squares kind of intersect as you move around. It kind of gives it a little bit of a life. Oh no, what happened just there? It had that weird movement for the tail. We might still have a bug. I wonder how far I can get with this. I think this is what we'll end the stream with. Once I lose, we'll end the stream. Oh, didn't move out of the way fast enough. Darn. All right, well, this has been a lot of fun, guys. Thanks for hanging out. Thanks for voting and taking the time. Anyway, I think this will be posted on YouTube. That's the goal, so that if you wanted to watch it again, you could watch it later. I know it's probably pretty boring to just watch me code for 2 hours and 17 minutes. But yeah, first stream, and I think this has been a success. So again, thank you all for being here and joining me on this. I guess that's the end of the stream. So, guys, chill and have fun.